Hey guys, Happy New Year. Hope everyone had a nice vacation. So if you can recall, before vacation we were looking at solving quadratic equations, and we learned two different ways of solving quadratic equations. One by undoing PEMDAS, right? So that's doing your PEMDAS backwards, undoing addition subtraction first, undoing multiplication division, undoing the exponents, and then finally undoing what's inside the parentheses in order to get the x by itself and solve for x. And that's for equations where there's only one x. So if you look at number 1, the equation only has one x. So we know that we can solve for this x by moving everything else away by undoing PEMDAS. So let's follow PEMDAS backwards. So the first thing we're going to do is undo addition subtraction. So I'm going to try to get the x by itself on the right side. I'm going to move the 13 by adding it to both sides. So that's going to give us 16 equals x minus 5 squared. So now in order to get the x by itself, I have to get rid of the exponent and the negative 5, which is inside the parentheses. Right, so order of operations backwards. We're going to undo the exponent first by taking the square root. The square and the square root cancels out. Be very careful here. Remember, the square root of 16 is 4 and negative 4. So two different answers. 4 times 4 is 16, but so is negative 4 times negative 4. And that undoes the exponent. Alright, so now because it could be a positive or negative 4, now you can break it up into two separate equations. Either positive 4 is equal to x minus 5, or negative 4 is equal to x minus 5. And then we solve for x. So plus 5 on both sides. And we get x is equal to 9 and x is equal to 1. And those are our two solutions. Remember to check to see if these are correct. You can substitute them back into the equation to see if it makes the equation true. And if you were to graph the quadratic, y equals, and set everything equal, move everything to one side, you would have x-intercepts at 9 and 1. So one way of solving a quadratic is by undoing PEMDAS. If you have an equation with just one x, you can move everything else away by undoing all the operations. Now in number 2, we can't do that because there's two terms of x's that I can't combine. So no matter how you rearrange, you will never get x by itself equals a number. So in this case, when we can't undo PEMDAS, the second method that we rely on is by factoring. Right, so let's go ahead and factor this. And remember, for factoring, you have to set the equation equal to 0 first because we're going to use the zero product property. So let's go ahead and factor this. No GCF. I'm going to break up the 2x squared into 2x and 1x. And then I want to find factors of 4 so that, using guess and check, when I multiply the inner terms and the outer terms, I want to make sure that it adds to give me negative 9x. So I'm going to do 4 factors of 4 are 1 and 4, and 2 and 2. I'm going to do 2 times 4 is going to give me 8. Plus 1 is going to give me 9, so I'm going to do 2x times negative 4, that's going to give me negative 4x, and negative 1 times x is negative 1x, and that would give me negative 9x. So we're going to factor, and then we're going to use the zero product property that says if you got two factors, a times b, that multiplies to give you 0. Remember, one of these has to equal 0, so either a is 0 or b is 0. Okay, instead of two numbers, we have two factor. So I'm going to rewrite it so it's a little bit easier to see. Once you factor it, we're not done. 2x minus 1 times x minus 4 equals 0. Now I have to use the zero product property. One of these, in order to make the equation true, one of these factors has to equal 0. So either 2x minus 1 equals 0 or x minus 4 equals 0. This is the zero product property part that you have to show. So solving for x, I'm going to add 1 to both sides and divide by 2. X is 1/2 or x is 4. Alright, and those are your two solutions. So when you're factoring, I just did guess and check, but if you like master product, you can certainly do master product. So two different ways of solving a quadratic, but under some conditions, right? In order to undo PEMDAS, you have to have an equation with just one x. In order to solve by factoring, we gotta ensure that our quadratic is factorable. So let's look at the next problem. Today we're going to learn a third method of solving quadratic equations other than factoring and undoing PEMDAS, and that's because sometimes you can't factor and you can't undo PEMDAS. So if you look at this problem, x squared plus 6x plus 2, there's more than one term of x's that I can't combine. So I can't rearrange the equation and isolate the x. Can't undo PEMDAS. And if I try to factor, notice what happens. I have x and x, and then two numbers that multiply to give me 2 and add to give you 6. They don't exist, so I can't factor either. Okay, so when you can't do either one, you can complete the square, which you can always do. So you can always complete the square. So if I want to solve by completing the square you guys have already done when we rearrange from standard to vertex form. It's just adding the boxes, right? Because this is not factorable, I want to make it factorable by adding an extra term. So I'm going to temporarily move the 2 onto the other side because that doesn't help us factor. And I have x squared plus 6x equals -2. And then I'm going to add an extra term to the left side to make it factorable. And whatever I add to the left, I know that I have to add the same thing to the right in order to keep this equation true. So what we're going to put into the box is 6 divided by 2, which is 3 squared, that's 9. Okay, and then remember the purpose of adding that extra term, that box, is so that now I can factor the left side. And it should factor out into 2 of the same factors because I've forced it into a perfect square trinomial so that it can factor. Okay, so then when this factors, x squared is going to be x and x. And then factors of 9, that adds to give you 6, that's going to be 3 and 3. So it's going to be x plus 3 times another x plus 3, which is x plus 3 squared. Okay, on the other side I have 7. And once you've completed the square, now you can get the x by itself because now your equation only has one x. You can now undo PEMDAS. So just like what we did in the first warm-up problem, I can now get the x by itself by getting rid of the square by taking the square root. Square root cancels out the square. I'm left with x plus 3 equals, now the square root of 7 I can't take because it's an irrational number, so instead of rounding I'm just going to leave it in the most exact form as the square root of 7. But remember, whenever you take the square root, you always have a positive or negative answer, so it's going to be plus or minus whatever the square root of 7 happens to be. And then last step, to get the x by itself, we're going to minus 3. And x is going to equal negative 3 plus or minus the square root of 7. And those are your two solutions. Negative 3 plus the square root of 7 and negative 3 minus the square root of 7. It's okay to write it together like this, using the symbol plus or minus, or if you like, you can separate it into two. That's also okay. All right, and just remember that if I were to graph this equation, y equals x squared plus 6x plus 2, these the solutions, negative 3 plus or minus the square root of 7, would be the two x-intercepts. They would be at an irrational number point, so it won't be a nice x-intercept that's an integer, but it's still there. Okay, so completing the square can be used when you can't factor and when you can't undo PEMDAS. It can actually be used even if you can factor, so it can always be used, completing the square. One good thing about it is it always works. Can be used for any quadratic, no conditions. Okay, and certainly sometimes if you can factor it, sometimes it's easier to factor it, but if you can't, rely on completing the square. Okay, so I'm gonna have you guys try the next two in your groups by yourself and then check with your groups. And so go ahead and pause the video, try it by yourself first, and then fast forward in the video to see if you got it right. And if you did, you can move on, and if you didn't, you can go back and watch. So for number 1, I'm going to add 1 to both sides because I can't find two numbers that multiply to give me negative 1 and add to give me 6. So I'm gonna complete the square and temporarily move the 1. X squared plus 8x equals 1, and then I'm gonna add my boxes to make the left side factorable. Whatever I add to one side, you gotta remember to add to the other side. What we're gonna put into that box is 8 divided by 2, which is 4, squared is 16. So now when I factor this, it becomes x squared. I'm gonna split into x and x, right? And then factors of 16 that adds to give me 8, that's 4 and 4. So it's gonna be x plus 4. And instead of writing x plus 4 again, I'm gonna write it as x plus 4 squared equals 17. And then once you complete the square, we can undo PEMDAS, get the x by itself by getting rid of the square and the square root, by taking the square root. I have x plus 4 equals plus or minus whatever the square root of 17 is. And then finally minus 4 on both sides. X equals negative 4 plus or minus the square root of 17. So 2 answers. Okay, and then number 2, a little bit tricky in the final answer, so be very careful. Again, I'm going to move the 17 by adding it to both sides, move the c value. That's going to leave me with x squared minus 6x equals 18. And then I'm ready to add my squares to both sides of the equation. And then in the square, we're going to add negative 6 divided by 2, which is negative 3, squared, that's 9. And then we're going to factor. So x squared is x and x. Factors of 9, that adds to give me negative 6. That's negative 3 and negative 3. So we're gonna have x minus 3 squared, and then 18 plus 9 is 27. I'm done completing the square. Okay, and then now I can solve for x by undoing PEMDAS. Take the square root of both sides to get rid of the square, undo the exponent. I have x minus 3 equals plus or minus, always a positive or negative answer, the square root of 27. And then I can add 3 on both sides. And we have x equals 3 plus or minus the square root of whatever the square root of 27 is. So here's where it gets a little bit tricky. See if you can recall this from geometry. Remember when you take the square root of a number, if we can't take the square root of 27, what we can try to do is simplify it. So even if I can't take the square root of 27, I can break the square root of 27 up into the square root of 9 times the square root of 3. That's 27. And if I break it up like that, at least now I can take the square root of 9, which is just 3. And then the square root of 3, I can't simplify any further. So if you can simplify your radical, please simplify it. And so the very last thing that we're going to do is do a quick review of simplifying radicals, because in your homework there will be some answers where there will be square roots that you have to simplify, or you can simplify. Alright, so review of simplifying radicals. This you did last year when you were doing geometry. When you're doing Pythagorean theorem, you had answers that had square roots, and when you're doing the distance formula, you also use square roots. So to simplify, all we're gonna do is try to break it up into factors that I can take the square root of, right? So the square root of 12, we don't know, but if I break up 12 into 4 times 3, at least we know that the square root of 4 is 2, and then the square root of 3 is inexact, so we're just going to leave it like that, 2 times the square root of 3. And then for 50, we can break it up as 5 and 10, but I can't take the square root of 5 and I can't take the square root of 10, right? So instead of doing that, let's break it up into 25 times 2. So when you're trying to simplify radicals, you're trying to think of, all right, what perfect square number can go into that number? How can I break it up? Does 4 go in? Does 9 go in? 16, 25, 36, all those numbers that you can take the square root of. That's what you're looking to see if you can break them down into. So square root of 25 is 5. And then you got the square root of 2, which we can't simplify. Okay, so properties of radicals. When you're taking the square root of 4 times 25, you can break it up as the square root of 4 times the square root of 25. And then that just becomes 2 times 5, which is 10. And similarly, when you're taking the square root of a fraction, you can break it up. This is the same as the square root of 49 divided by the square root of 4, which becomes 7 over 2, and you can leave your answer as a fraction. Okay. What you can't do, common mistake, be very, very careful. What you cannot do is when you have the square root of, let's say, a plus b, this is not equal to the square root of a plus the square root of b. When you're adding, you can't split them up. They're not the same. And same thing when you're subtracting. The square root of a minus b is not equal to the square root of a minus the square root of b. So when you're adding and subtracting inside square root, can't split them up. But when you're multiplying, dividing, you can. Alright, so last thing, try the next 2 problems on your own or with a partner, and then check back with this to see if you got the correct answer. So 40, I'm going to break it up as 4 times 10. Square root of 4 is 2 times the square root of 10. Some of you might say, well, can I break up 10 into 5 times 2? You can, but that doesn't help us, right? We can't take the square root of 5, and we can't take the square root of 2, so that doesn't help. 32, I'm going to break up into 16 and 2. And that's going to give me 4 times the square root of 2. Right? And if you decided to, if you didn't break it up as 16 and 2, if you think of 4 and 8 first, that's fine. But then just keep breaking up the 8. 8 is 4 and 2. Right? So then the square root of 4 is 2. Square root of 4 is 2. Square root of 2. I can't simplify. So you still end up with the same answer. Alright, so for the rest of class and for your homework, I'm going to have you guys work on the worksheet that's attached, solve by completing the square. And the answer key will be posted on Schoology, but please check your work, but show all your work in order to receive full credit.